Right, we can start. I saw your answers as well. Okay, not all of you attempted the questions, the worksheet. But Kim, you only did MCQ also. So total only 10 of you tried. We have 20 in the list. Okay, I have 10 answers. So maybe you want to look into this. Okay, do your work. Now, these are some of the formulas that will be common, okay, for the Sec 2 electricity, right? The first formula you are very familiar already. Okay, R equals to V divided by I. So if you want to play around with this formula, okay, usually I show you in the form of a triangle. Okay, so if let's say you want to calculate current instead, okay, so it will be V divided by R. Remember this? Okay. Then if it is voltage that you are calculating, you can take V equals to I times R. All right. Then power, this is probably something new. Power equals to voltage multiplied by current. We will be using this formula in our lesson today. Okay, so this is one of the formulas for electricity. Then, of course, the series and parallel circuit, right? If you are looking at the voltage, okay, so the voltage is actually a summation of the different components. All right, add them together, you will get the voltage for this particular circuit. Okay, if it is placed in parallel arrangement, okay, they are going to be equal. Each of them will be equal to each other for the branches. Now, if you are looking at the current, okay, in a series circuit, current will be the same at any point in the circuit. Okay, whereas in a parallel circuit, right, the total current for the entire circuit, you will have to add the current of the individual branches together. All right. Not necessarily will be tested for all your schools. I want to reiterate this. Okay, some schools only test the very basic, what is necessary for Sec 1 and Sec 2. Some schools test a bit more. You will have a very clear idea when your teacher covers this topic. Okay, some of you also told me that you have finished the topic. Okay, like Enlak says that the school actually requires him or his class or his whole level to study a bit more into the Sec 3 syllabus. Yep, so he is doing more than what is required. Resistance, I've shown you how to calculate the last lesson. All right. So if it's arranged, if the components are arranged in series, okay, basically you sum them up. If it is arranged or if they are arranged in parallel, okay, you need to take the reciprocal of each of the values. All right, and you calculate accordingly. Okay, later we will see some questions as well. So again, series and parallel, you learn this in primary school also. If any of the component, let's say, is damaged, okay, there will be an open circuit, current cannot flow. Then if it's a parallel circuit, right, any of the component that breaks down will not affect current flow in the other branches, okay, because they all have their individual path to travel in, to move in, to flow in. Okay, this is another one, similar one. All right, I put in two and you can decide which one you prefer to keep for your own revision. Okay, question 1. So we need to do more calculation. I remember you did ask me about electricity, okay, about the calculation, and these are the common ones being tested. You need to know how much it costs to use an appliance for a certain period of time, given information on the power rating, okay, as well as the cost per unit of electricity used. So over here, okay, they are telling you, all right, 1 unit of the electricity, 1 unit of electricity is represented by 1 kilowatt hour. Okay, this costs 40 cents. How much will it cost you to use a 60 watts? So this 60 watts is the power rating. Okay, this is the power rating. All right. For the washing machine is being used for 30 minutes. So the first thing for you to think about is once you look at the unit of the electricity, which is kilowatt hour. You need to know, okay, whatever information given to you, convert to the required units. So it's not watts you are working with, you are working with kilowatts. So first thing you do is to convert this 600 watts into kilowatts. How do you do that? Do you all know how to calculate this? If you do, just type for me how many kilowatts will this be converted into? All of you, let's see, I only have 1, 2, 3, 4 of you turn on the video. Okay, good, Jinshen, that is correct. All right, yeah. So you put 0.6, that is right. Why 0.6? Your homework ate your camera, huh? What do you mean? Usually is the pet, right? The cat or the dog ate your homework. Yeah, now you're saying your homework ate the camera. Aiyo. Okay, so to convert watts to kilowatts, divide by 1,000. So yes, Dingshen, that is right, 0.6. And how do you get that value? Oh, 30 minutes. But we are going step by step. So we are converting watts into kilowatts. Yeah, no problem. So now, next step is convert this to hour, because we want to satisfy the requirement of the calculation, which is in, the value for 1 unit of electricity should be kilowatt hour. So to convert this to hour, we know that this is to divide by 60, right? 60 minutes, and you get half an hour, which is 0.5. Okay? So after that, what do? You're going to find, okay, total energy used. Total energy used means, okay, you use that particular electrical appliances for a certain amount of time, right? Okay, so 0.6 kilowatts multiplied by 0.5 hour. And what is this value? 0.6 times 0.5. Is that the one you put down 0.3? Correct? So you immediately converted to kilowatt hour just now. Okay, you missed out the H. If I give you feedback now, if you look at your answer that was being keyed in 1 minute ago, 2 minutes ago, you put 0.3 kilowatt, but it should be kWh. Okay? Without the hour, yeah, you'll be wrong. So after that, you are going to take 0.3 to calculate cost of electricity multiplied by, okay, this is like per kilowatt hour, right? 40 cents per kilowatt hour. And what do we have? 0.12. Should be no problem. Let me check your answers. Yeah. Okay. Yeah, Jingshen, now you know how to do it. You got it wrong. But no worries. Yeah, I would rather you show me you don't know and then I guide you along than for you to, try to figure out on your own and then you didn't really understand. Because I have students who actually went to do the worksheet twice. And the second time, they actually put in all the correct answers after they have looked through. Okay, after they have looked through the first trial of the worksheet, they look at the suggested answer, they do it the second time and everything is correct. But I wouldn't know what is your error. When I generate your answers, right? Whatever I see is the latest copy that you have submitted. Okay, the latest copy that you have submitted, which is the last worksheet that you have done. So it could be your second try. It could be your third try. Okay, so unless you are submitting it only one time, then I'll be seeing the correct one. You made quite a bit of error, but not to worry. So when you are making a lot of mistakes, you will definitely improve along the way. Okay, Jingshen? I don't want you to feel disheartened. You might want to consider Saturday also, Jingshen, if you can. Think about it. Yeah, you can ask your mom. Okay, answer is A. Question 2 now. A person uses 3 kilowatts electric fire for 2 hours and then Okay, he or she also uses this 2 kilowatt heater for 4 hours. What is the total cost if the price of electrical energy is 5 cents per unit? Okay, per unit is kilowatt hour is given to you. So 1 kilowatt hour costs 5 cents. Okay, so we have to look at the first part here and the second part here to determine how much electrical energy is being used. Okay, so how much energy is used? Okay, so this is good. It's in kilowatt hour already. So basically the first one, 3 times 2. All right, you can do it together instead of step by step. Okay, so 2 kilowatts. This is being used for 4 hours. So total energy, I have 6 kilowatt hour here plus 8 kilowatt hour. Total will be 14. All right. So every 1 kilowatt hour is 5 cents. Then 14 kilowatt hour, how much would that be? Okay. What is your answer? Oh, Jingshen, that means that you don't come for Tuesday anymore. You only come for Saturday. Ah, that's the meaning. Okay, Birkin says it's 70 cents. Yep. So total cost will be total amount of electricity times 5. Okay, I prefer to put unit in. But it's up to you to put, because I know the school actually allow y'all, okay, the intermittent working, right? No need to put units, but the final one, you have to put it down. All right, so you should have your answer here, 70 cents. Okay, yeah. Harvard only made one mistake. Let me see, How Lun, the last few. Okay. Jimin, middle, right. Birkin, okay, Birkin also very few mistakes. Can, let's go on. Now, stop me if you have any question. Yu Yuan says, remember, Saturday is the best day as you can do anything you want because you have Sunday to finish your homework. So don't do it. You're telling everybody don't go to Saturday, right, Yu Yuan? Yeah, my goodness. I have a lot of people asking for Saturday. Why? Because weekdays they are so tired and a lot of homework to complete. So that's the reason why I opened up. I also want to have Saturday as my break, isn't it? Okay, but yeah, for y'all lah, I will open up one more class for sure, especially those who actually requested for it. Okay, so let's continue now. Okay, question 3 says 1 kilowatt of energy costs 25 cents. Okay, Irene's family spent $50 on electricity bills. So how much electrical energy was used? Yes, Haolun, let me go back first. You mean the working, huh? Yeah, you can take a screenshot. If I'm going too fast, you can let me know because we had 1 week break, right? So sometimes 1 week can cause you all to forget quite a bit of things. You need some time to pick up from where you left behind. Harvard also didn't attend the last tutorial, right? I suppose you were overseas? Yeah, okay, sure. Now, I want someone to try this. Okay, let me see. I should deactivate chat with everyone. So y'all can type your answer to me. Now, I want you to try this question and you tell me how you get your answer. So that means you have to show me your working. Okay, show me your working. Type into the chat and send to me. All right, Raman, are you here, Raman? Just to be sure, you are in front of the laptop. Casper, are you here? Okay, good. Good, okay. Okay, I can see Haynes working. All right. Good, okay. Yes, Harvard, that's correct. Jimmy, re-look at your working now.